broadband. So with that, I would like to share this presentation today, just to answer what is the 5G all about. Okay, and second thing maybe is concerned with the what we call the standardization. Standardization means, as you know, that 3G is already global standard. It's coordinated by ITU. You go to everywhere, you can do roaming and all those things. Whereas when you compare before with the different first G, second G, that cannot be done. But what is the 5G? What is the standardization process been done to achieve those requirements? And also the spectrum. We're looking into 2G, 3G, 4G, the spectrum, if you look all below 6 gigahertz. You have 900, 1800, 2.1, 4G, 2.6 for LTE and so on. But you see that in 5G, that's why it's still a bit different. Whether the spectrum is still below 6 gigahertz or we are looking into a new things, new era, new spectrums. That is the thing that you want to see. And again, the use cases. Use cases means you are talking about currently just talking about try to get more speed, try to access internet faster, to get more capacity. But when it comes 5G, as mentioned, it's become vertical. Other industry can come in. Okay, automobile, healthcare, and all become that. These are new use cases created which open the opportunity for more business, more to can coming up. And I would like also to share in Malaysia what are the initiative has been done toward the 5G implementation. And I come from the University Technology Malaysia. It's one of the technical university. Our university focusing more on engineering, technicals, and there's one center in our university is focusing on 5G wireless communication. Is wireless. I want to share what we have there and what are the research that we are doing related to the 5G. So first one, if you see here, it's very clear that 1G is just for voice. You want to have mobility in voice. Second G, you're looking from voice to, because this is analog. When you move from analog to digital 2G, you can also not only transmitting voice, but you can transmit data as well. But the data is very slow. GPRS, I think you know that about only 100 kilobit per second. Then they improve to H, maybe about 300 kilobit per second. Okay, for that one. Then when you move further to 3G, then 3G, meaning that at least they need to have 2 megabit. There where broadband started. 2G is not considering broadband. For example, if you some in my country, if they say that there's a 2G service only, they might say that no service. They want to have speed. So 3G can provide that, besides provide the global roaming. But when you move from 3G to 4G, you're talking about enhance the broadband. You have to have more speed. Therefore, that's why they change in the technical term, multiple access from FDMA to TDMA technology, then they go to CDMA. When it comes to 4G, they need to have more spectral efficiency, meaning that with the same base, with the same spectrum that bandwidth you have, you can put more users, more bits can be there. They have to change to OFDMA. That's why technology used in 4G is the OFDMA. And then what will be the next? There's a question. Whether you want to increase further the speed or maybe looking to other things as well, that can incorporate. That we will see later. And interesting to see that those generation happen every 10 years. Started when cellular been introduced. Cellular system that revolutionized mobile communication. Before cellular, there is no mobile communication not so popular because of the spectrum utilization and the technology and so on. Okay, so it happened. That's why we are looking 2020 5G will be finalized implementation. So this, when we're looking into in terms of this broadband, you're looking into 4G. Actually, the real 4G that ITU said should be 1 gigabit, low mobility, meaning that if I am here accessing the mobile internet, the speed has to be at least 1 gigabit. If I travel in fast train, in Europe you have fast train 300 kilometers per hour. Connection to the internet has to be 100 megabit. That is the requirement. But when you move further to from 4G to 5G, of course, you can see that it enhances further the broadband. The broadband has to increase 10 times, at least 10 gigabit. No? That's one thing. But 5G, not only that. 5G talking about vertical now. Looking into low latency critical mission. They're targeting 1 millisecond. Latency means round trip. Like when you make a call, they return back, there is the latency. They read out there. So, and they're talking about 5G all in cloud. Everything sent to the cloud back to here. And use just like a real time. Okay, for that. That's why there's some of the critical mission use cases are very important. Okay, and then beside that there is a, IoT now become important. Not only people connecting to internet, but things surrounding us also need to be connected to internet. That's IoT. In 5G, all these things become standard. At the moment, IoT, they're introducing narrowband IoT and so on. But in 5G, it's why here, ITU has set the vision that I mentioned to you. First, enhance the broadband. At least speed has at least 10 times more. Second thing, this is a new thing that introduced in 5G, is not available in 4G, which means ultra reliable, low latency. That's why I mentioned to you, autonomous car, remote surgery can be done. Like I am controlling the drone. Drone is here, I'm controlling there. In 5G, the person controlling the drone can be anywhere. It's like that. But you should be. Remote surgery, the same thing. And autonomous car, when we're talking about autonomous car, maybe safety. Because if with 1 millisecond latency is very close, you still can apply the brake. Still, it won't collide. So that is the thing that some of the example of use cases. And the third one, as mentioned, mischief type communication. Things now connected. It will be look like this. You will see that maybe the base station of 5G there, it can provide 10 gigabit at least to this location. Fiber to home, maybe some issue because of the last mile, but with the 5G, you can provide the capacity to all these things. And things are all connected to here. They're talking about 25 billion, before they say 50 billion connection. Now maybe they reduce to 30 to 25 billion connected devices. If you see the world population, everybody have phones, for example, 7 billion, 7 billion. Which means 25 billion mean that 2/3 surrounding us are all connected to internet. See, if you see here, for example, device-to-device communication. You can say you have a car. Your car have a device. Yeah? This device can talk to this device inside the car. If something wrong with this device, maybe this will send back to the data center or then you receive a call from the data saying that your car have problem. Because this is just an example. This is you can see all are connected there. That's why we're talking about massive connectivity. The other thing that already mentioned requirement is 10 gigabit. Okay, and then latency 1 millisecond. It has to be ultra reliable. Okay, that is very important. That's a thing. And then of course battery life has to be long and so on. I have a video here, but maybe I don't know, can we play? But anyway, this is just the video just to show the concept of the latency. Maybe you can, is it possible the mouse is working? No, so it's okay. I think I will skip this, but I will go to the later on that one. But you see here, 5G in 2020 need capacity. 3 things requiring capacity. How to increase battery internet. First, you need to have good signal-to-noise ratio. So it means what? You have to be close to the base station. It's a small cell. Right? You always close that thing. That's why in the 5G, the beam you see 5G, the cell of 5G only 200 meter. This is one of the vision, because 5G cover different bands. It's one of the use cases example where you need to have low latency and high capacity. It has to be 200 small cell here, and the beam here is steerable beam. The beam is moving. You're always pointing to that direction. Okay, so you don't require high power. I give you example. If you have this lamp, bulb, that way, of course, the only electromagnetic spectrum that you can see with your eye is the light. Other you cannot see, but they are all surrounding you. If this energy you want to cover this room, for example, you need to have certain wattage, certain power. But if I can, and the level I'm receiving here, this light where I can read, no, is enough to have this, but it has to be spread out all over. But if you can focus the beam just to you, the power that you need to transmit can be very low. And then when you move, the beam follow you. It's just like a spotlight. Okay, so you don't have, and then you can utilize the spectrum. If this channel being used here, the other channel can be reused again there, they won't cause interference and so on. So this is just an example. This is what one of the use case example that 5G can support by having these small cells. Other thing, you need bandwidth to get capacity. Below 6 gigahertz here, 2G, 3G, 4G, all below 6 gigahertz, no more spectrum. They know have to move to higher band. That's why in 5G, they are also talking about millimeter wave band here. 28 gigahertz is an example, okay? So you have more bandwidth over there. And of course, antenna size. When you move higher, your antenna become smaller. Then you can have very compact antenna. You can have just on the wall, like what you have here. This is more than 100 array here, okay? And they introduced MIMO. MIMO again to increase further the speed. MIMO means multiple input, multiple output. Input means from your, say your base station to the air is called input. This is, if you have multiple mean more than 2. In the other side, you have output from air into your receiver. So you have more than 2 antenna, then we can characterize multiple input MIMO. Huh? This is one. So it will be massive MIMO will be available there. So these are the things why we need to have that spectrum in this also. Not only below this, they are also above this. Okay, this is what happened. The beam will be following like a spotlight. There will be multi-beam. This is the concept, one of the concepts in the 5G. Okay, then the important standard. You see first generation, analog, multiple standard. UK one standard. Even in Europe, we have multiple standard. The problem, you move from one country to other country, roaming cannot possible with different standard. Then they move to second generation, regional standard, GSM. It's a regional European standard. US have different standard. Japan have different standard. So when you go to Japan at that time, you cannot make a call because roaming is not possible. GSM, because it's the most successful second generation because it's been used 80% worldwide. So that's why you go to country where they have the same standard, they can do roaming. When it comes to 3G, it has to be, one of the things to be global standard. That's why ITU come in to coordinate the standard. Okay? That's why they call it as IMT 2000. Besides the global standard, they also need to cater for broadband, the multimedia, 2 megabit at least. From here to here, there you see the improvement. They increase further the speed from 2 megabit to 14 megabit by using HSPA. HSP plus can be 28 megabit. But when you go further to 4G, CDMA technology cannot provide anymore. But they have to go to another different multiple access called OFDM. Okay, so those are the things. So now going on further to toward the 5G. 5G will be not finalized the specification yet, still ongoing consensus, but they probably some type of OFDM will be used. That's why they say here by 2020. So the process of this standardization will happen. ITU set the vision requirement. This is where they set the requirements, said enhance the broadband, ultra reliable, low latency, and also the massive machine connection. And then ITU set the requirement for evaluation. Now consensus is ongoing in ITU to finalize. But even we have already a prototype available that can meet that requirement, but the specification might be not the same. They have to compromise on that until 2020 when everything is finalized. Then you have this. Only you can have the phone with 5G inside that, right? Okay, so those are the process standardization that's ongoing. This is the thing. In ITU, as I already described, they set a vision, the requirement, proposal, and specification. In 3GPP, the one that looking on the release, no, the LTE and also WCDMA, they are looking. Currently, they already finalized the release 15, which means part of the enhanced broadband in 5G already been done, but now they are looking for the, before they can finalize the actual specification. Usually the pilot trial of 5G already been done in Korea during Pyongyang Winter Olympic this year, early this year, demonstrating about the 5G. And the first commercial 5G that will happen will be in Tokyo, 2020, during Olympic game. So that is the time when, by that time, everything is all done. No, we are talking about looking to that. Okay. Second thing important, spectrum, frequency. When talking about wireless, spectrum frequency is very important. There is a natural resources. You use, there are two types, one licensed and one unlicensed. Unlicensed means everybody can use, like Wi-Fi, Bluetooth, and all those things. You share, okay, and microwave oven and so on. But license is been assigned to the telco operator, service provider. They are given this block of frequency. They only can use and plan it. Another block, another operator. Another block, another, and so on. So that is the thing. Okay. So if you look here, moving to 5G, there are two paths. One looking into high bandwidth, low latency. Yeah. That's why you're talking about two use cases example. But again, 5G also need to support massive connectivity, machine IoT. Where IoT don't require bandwidth, you are talking about sensing sensors from the smart meter, from any, it's not only require very low bandwidth, and it's not transmitting all the time, just updating and so on. Okay, so there's the thing, and then the battery life has to be longer. So there are two pathways. So it has, the spectrum need to cater for both examples. So that's why we in 5G they're looking into three different bands. First, they're talking about higher band. Higher band is 28 gigahertz or millimeter wave band. This is where we are talking about beamforming, low latency application. This is to cater for a given, like remote surgery and so on. Second is the mid band. Mid band is the one that to enhance for the mobile broadband. Okay, for example, you're looking into the 3.5 gigahertz band. Now currently been sharing with satellite. But that is most countries, they're looking at potential, beside the existing band that they already have. And another band is the lower band, below 1 gig. This you require coverage. Why you need lower? Because your coverage, if you have a base station with the same power, same height, lower band can cover very large coverage. Compare, if you go higher, the loss will be higher, your cell becomes smaller. It's very important for the use cases of IoT machine type. So these are the three bands that been considered. And those bands will be finalized by next year, WRC, World Radio Conference 2019, okay, before the standardization being approved. So these are the examples there. You can see that for higher band, especially talking about in millimeter wave band, they're looking into high bandwidth, high density, low latency. Mid band to enhance the broadband, and lower band basically you are talking about coverage like machine type or IoT and so on. And this is the different type of the cell. It can be small to 100 meter. What I'm saying that just now 200 meter is basically categorized here. But it also can be a small cell to enhance the broadband, and it can be a large cell for the IoT. So these are the spectrum. You can see that it covers whole range of the spectrum that required comparing to the previous. So this will be the what happened in future. The orange one will be all the 5G spectrum cover. The green is the 4G. In future, if you have the spectrum of a certain bandwidth, if you implement 2G or 3G, and you're using the 4G in the same bandwidth, 4G can support more user. That's why some country they already phase out 2G. Singapore, our neighbor, already phase out. Some country like Taiwan also they are phase out. They're living with 3G. Some of even 3G they are Because 3G with the same, if you implement 4G with the same spectrum, 4G can provide better efficiency, meaning more capacity to the user. That's why most countries. But in future, we can see what will happen. There will be because of 4G and 5G. Because you're looking, when you move further from 4G, 5G will be some will be continuation from what 4G have, and some will be the new radio. That's why they call it NR, new radio to cater for some of the thing. So I think in future, what I'm thinking that this 2G, 3G will be phased out, will be left with this to cater 4G and 5G will be coexist to provide the broadband and also to provide the new use cases. Example, but currently, some countries still require 2G because there are some network using GPRS, using the phone, the 2G phone. Because 2G phone, the battery life can last longer comparing to the smartphone and all those things. Okay, so these are the countries that already been considering those bands. For example, in US, in Korea, Japan, they already have some of the allocation of the spectrum, and both below 6 gigahertz and also in the millimeter wave band. And you're talking example in Korea. Korea already have done the exercise where they are giving in the 28 gigahertz band 3 operators. One operator is more than 800 megahertz of spectrum. You need to have a contiguous to provide the services use cases. In 3.5, they also have the other 3 operators. Okay, so that is what happening then. And what important here, we can see that the trend, because most of the spectrum are all IMT spectrum. It's a technology, you can implement 5G in lower band or mid band or higher band. Because it depends, you can do refarming. That's the thing. So that's why this 3 band is important for 5G. 700 below 1 gig. The mid band 3.4 to 3.8 beside the existing band that you have. And the issue here in some country might be maybe the satellite. They're using C-band downlink. Because satellite, when you're talking about downlink, you have a receiver very sensitive. You have a base station, even not just adjacent to that, they might interfere. So they have to look into some sort of a guard band or refarming to cater for that case. And the higher band, of course, 28 gigahertz to increase the capacity and so on. Okay, this is just example of use cases. We have some collaboration with the Tokyo also in Japan. This is Dr. Sato from ARIP and then also one of the university. We are looking into these examples of the use cases. Here is where they have done a trial for 5G, high definition, high realistic video streaming. Because this is important. 5G, when you're talking about, it can support 4K, 8K, meaning that doctor can be anywhere, you can diagnose the person like you are in front. Okay, and second thing, you can see like the remote surgery I mentioned to you, the low latency means the robot will be operating, the doctor can be, some cases critical, has to be done. If you don't do that, then will be no life or death and so on. But that is happened. And now you see that we are a shortage of specialists. You can share, specialists can be in one location, but the patient hospital can have all these facilities that we can get that done. Okay, this is the example. Another, and I think this one you're talking about, it can support entertainment in high-speed moving vehicle in the retreat, right? So this is the trial that have been done in Japan, and this one is for example, in the stadium. We can have also some sort of this entertainment in stadium, high definition video streaming, and so on. With 5G, this can cater all those. Because the features that you have. Okay, another thing is here. You can see that you have an excavator outside. Since that time, the operator don't have to be inside that. You can be in your office, controlling that, like you are inside that. This is because of the latency of 1 millisecond, like the real time. Okay, maybe there are some critical mission. You want to go underground, if a person go in there, very critical, disaster. This is not necessary to be there. He can be controlling what is happening inside there and so on. So this is some of the features. You can see that it's become vertical. Many industry will come in and get from there. This is another example like platooning. Platooning means, you know, the truck. Going there, but the truck behind this, they don't need a driver. They will follow and all those. So in 5G, with this is possible. Okay, so this is just an example of the use cases that